Alright, so we're reviewing the final exam for MET-121. So step 1 is to import the CAD model. You want to import and position the part model in 15 minutes or less. You will be completing this final exam sitting at the machine, so you have the option of either doing the offline programming, where you use the CAD model, or the teach-in method, where you take points directly off the part. The advantage of the teach-in method is that you don't have to position the CAD model, so if you have difficulty with that, the teach-in method is what you want to go with. All right. But I'll show you both. So we'll start off by importing our CAD model. So I've already opened up Calypso. And now I'm going to come over and do an automatic stylus system change. And I'm going to grab that 3 by 50 millimeter stylus. And we'll open up the blueprint as well. So for this, I'm going to use an alternate version of the blueprint that's very similar. The final exam will not look like this. Or it'll look similar to this, but it won't be the same dimensions. So you can watch this video as many times as you want in preparation for the final. Just know it won't be exactly the same. Okay, so for starters, we want to import and position our CAD model. And based on looking at the orientation of this print, I see the 2 rectangular cutouts are in the back left. So when we import the model, it's going to come in this orientation here. Where these 2 rectangular cutouts are in the back right. When we import it, we're going to have to rotate it 90 degrees, so that way those 2 cutouts are in the back left. So that'll be our first move. To do that, we'll pop over to Calypso. We'll create a new measurement plan. The first thing I'm going to do is save this measurement plan, so that way I know exactly where it's going. So File, Save As, and I'm going to save this as my initials and an underscore and MET-121 Final. I'll put that right in the Downloads folder. So I do not recommend working off of your flash drive for this. Put it in the Downloads folder, copy it to your flash drive at the end to back it up for your records. You're going to have much more system stability that way. I've seen some weird system instability with people working off of flash drives.
Yeah, I learned that the hard way.
Yep. Yeah, you can back it up periodically on your flash drive. Hit save and then copy it to the flash drive if you're nervous about it, but I don't recommend working off the flash drive. So the first thing we want to do is import our CAD model. So we'll go CAD, CAD file, and load. We'll grab our CAD cube and say open. I'm going to come down here to the bottom and I'll turn on shading just so I can see what's going on. And if we compare our blueprint to our CAD model, you can see that it does need to be rotated exactly like I said. So we have a couple of options here. Probably the easiest is to go CAD, Modify CAD Entities. We'll come over here to Transformation tab. Nothing's highlighted right now, so we will have to click on the model first to highlight it in pink. And I always forget if this has to be positive or negative, but I think we want to rotate 90 degrees about the Z. So I typed in 90, I hit the Tab button on the keyboard, and that gives me a little preview of what's going to happen. Now, as soon as I preview that, if it looks good to me, I'll say Apply. And then I'll say Close. So does the model look how it looks in the real world? And does that match the print? Well, for starters, let's move our actual part in the real world so that way the cutout is in the correct spot. Just confirm that here. That looks good. Cutout's in the back left. That's exactly what we want. We do see the same thing on our computer screen here. And notice that the gnomon is at the intersection of the top, the back, and the right side. Is that correct? Is that how it should be? Well, the answer to that is right on the print. We have datums A, B, and C. That's called your primary, your secondary, and your tertiary datum, respectively. Primary meaning most important, tertiary meaning least important. So when we do our alignment, we're going to set it to the top surface. We're going to create a line on the back surface. we're going to create a point on the right surface, and the intersection of those three will put you at this back right corner right here. And just based on the way this works, yes, that does happen to be from the correct location. Now, the alignment may be in a different spot on your final exam, so you have to make sure that you match whatever datums A, B, and C are. If you plan on using the CAD model, you have to make sure that you've positioned it correctly. In other words, if datum A, B, and C was the top, the front, and the left side that I just showed you here, that gnomon would want to be at this corner. It's up to you to position the CAD model correctly. Now again, you don't have to use the CAD model for programming. I think it makes it easier. However, if you have difficulty positioning it, if it takes any longer than 15 minutes, just stop, use the teach-in method instead. I have had students take more than 45 minutes to position a CAD model, and then they didn't have enough time to complete their final exam. So don't have to use it, it's there if you want it. All right, so that's that. Now we can actually do a combination of the teach-in mode and the CAD mode. It's really up to you which one you want to do. In this case, I imported the CAD model mostly because I know we're going to have to do the simulation later and because I want to be able to show you how to do it. But at this point, I'm going to switch over from the offline style programming where I take points off the part, and I'm going to do teach-in instead for the alignment. I just think it's easier that way. So to switch over to the teach-in mode, I am done on the CMM tab. I know what my machine is. I already have the 3x50mm stylus that should work for all of our features. Then we'll come to the measurement tab, and we'll go to base start alignment. We'll accept the default to create a new base alignment, and then we'll just start taking points like we normally do. So the first 3 points I'm going to take will be on the top surface. I'll touch 1, 2, and 3. And we can see that became plane 1. I'll say OK, and plane 1 is now my primary datum. Primary datum is used for the spatial rotation and the Z origin in this case. All right, my next move is I'm going to take 2 points on the back edge of the part to make a line. 1, 2. See, that became a 2D line. I'll say OK. That populates the planar rotation and the Y origin in this case. Now I'll come over and touch 1 point on the right side of the part. That became point 1, and I'll say OK, and that populates my X origin. And I say OK here, and look what happened. So my CAD model was in the correct spot, but now that I've updated my actual position on the machine, the CAD model is no longer in the correct spot. And that's because the CAD model is still up at the machine's origin, and I just gave the machine real data in the real world that the part is actually down here. So no big deal with this. I'll go CAD, and actually we have to come into View and Delete. And then I'll go CAD file load. I'll just reload that same CAD file I had before. Notice how the origin comes in correctly?
I have a question.
Yep.
If you were to take the points first and then download it, it would pop up where it's supposed to be.
If you took the points on this first, you would have to then do a manual alignment on the real machine to get them to be in sync with each other the same way that you do it when you write programs from home.
And to delete the CAD that was view, delete.
CAD,
CAD view.
view, and then delete. Now, here's the good news. If you end up with any sort of misalignment of the CAD file like that, if it's causing you problems on your exam, and you forget how to delete the CAD file, or whatever, just call me over, I'll delete it for you. You can just use the teach-in method the whole time. All right, so that's your out if you get confused with that process. Notice when I brought the CAD file in, it's still the original CAD file. Its orientation is incorrect. Because I deleted it and re-imported it, I have to go back and rotate it again. As a quick review of how to rotate it, we'll go CAD, Modify CAD Entities, Transformation, click on the model, we'll grab our Z rotation here and we'll rotate that 90 degrees. Hit tab for your preview. If you like it, hit apply.
You don't have to put it on the base plate. About that.
It actually already went on the base plate when I picked up the parts off of the table. In fact, you'll cause problems if you try to put it on the base plate. You want to let your manual alignment put it in the correct spot automatically. In fact, while you're doing this, there's a glitch in the software where if you try to put the part on the base plate using the CAD, the machine will rapid the probe into the table. So your speed dial should be all the way down when you're doing that. All right, so that's something that we haven't gone over yet because you've been writing programs from home. You never had the option of taking up so much machine time to do either option. But that's something that I discovered the hard way. Luckily, I had the speed really low, and I watched it come over real slowly, and it was moving towards the table. I said, what's going on there? You know how when you position the models at home, if you try to put them on the table, everything kind of moves for a second, and then it jumps back? It does that in the real world, too, on the real machine. Just something to look out for. Okay. So, just confirming, because I did delete and reload the CAD file, do we like our alignment here? Do we like where our X, Y, Z triad is based on what we see on the print? Datum A is the top, datum B is the back surface, datum C is the right side. Our rectangular cutouts are in the back left corner. Do we like that? Yep. All right, great. Now, here's a nice thing about using a CAD model. Now I can go clearance plane and just say clearance plane from CAD model and just accept the defaults on the distance. No, I don't want to update my clearance planes. If I were doing this using the teach-in method, I wouldn't have the CAD model. So I would have to drive to the appropriate location. So for plus Z, that would be a little bit above the part. And then I would have to hit the missile fire button on the controller. And I would have to do that again for the X positive over here, for the Y positive over here, X negative over here, and Y negative over here. But it can be set either using teach-in or using the CAD model. 6 of one, half dozen of another. All right. So now we're going to switch over to our features tab.